Hello everyone, hello everybody. So today I'm going to walk you through a predictive analysis I performed with the supervised machine learning algorithm using the linear regression model. But then before I proceed, my name is Chomobia, a data science and business analytics intern at the Sparks Foundation, and the purpose of this task is to build a machine learning model that would predict the scores of students based on the hours of studies. And first and foremost, I have to import my libraries. These tools would help me perform the analysis, the functions and the tools they are needed for this analysis, and they are the pandas for my data manipulation, the NumPy for the arrays, the matplotlib for visualization, the Seaborn as well, the sklearn for the linear regression model. So I bring in my dataset, loading my dataset from where it is located, which is this URL. My dataset is here, so I have to bring it into my Jupyter notebook, name my dataset student underscore data. So that means wherever you see student underscore data, I'm referring to my dataset using the pd.read underscore CSV to bring it into my Jupyter notebook and onto a quick overview of my datasets. Starting with my datasets dot head, the student underscore data dot head 10. When I'm viewing the first 10 rows of my dataset, it could be 5, it could be 20, it could be 7, depending on the parameter. Here I'm having 5, 10 rather. So I'm viewing the first 10 rows of my dataset onto dot shape here, and I'm having 25 and 2. That's to show I have 25 rows and 2 columns in my dataset. And on to dot info here kind of provides a general information on about my datasets, the basics actually. So I'm having 25 entries, and my datasets started from 0 to 24, 2 columns, no null, and ours are majorly floats. That's to say they are decimal numbers, and the scores are integers. That's to say they are whole numbers. Then the dataset has a memory usage of 528.0 bytes. Then on to dot describe. Here, this provides this provide a kind of information on the distribution and variability of the data set, and I'm having count, the mean, standard deviation, minimum and the maximum. And on to visualizing the data sets here, to make a visual of my data, and voila, here it is. And from the graph, it is evident there's a positive relationship between hours a student study and the score he or she is likely to have. Then on to preparing my data set here. I'm the first thing I have to do in preparing this data set for linear regression analysis is to first divide the data into features and levels using the ilog function, and this would divide my data into two numpy arrays. And at least for the burst, my model will understand it's actually working with two variables, which which are the x and the y. So the data set is divided into x and y numpy arrays, and on to splitting the data into training and testing sets. Like it's very important in every machine learning especially using the linear regression model, and it's very important to split the data into training and testing sets. First of all, it will help the model not to overfit, and secondly, it would evaluate or help evaluate the performance, the accuracy of the model. And here I'm still using the sklearn, importing my train underscore test underscore split, and using my test size as 0.2, meaning I'm going to use 20% of the data set for testing, and the remaining 80% is going to be allocated to training. And here my split is successful, and on to training the model. Here my model is being trained here, and my data set fitted into it. So I have a model already that I'm going to make predictions with. So my model is ready, and here I am making a visual of the regression line. The regression line here, having an upward trend, and looking closely here, um it shows that the more time a student spends studying, the more, the higher or more scores he or she is gonna get. So that's the meaning, that's what the upward trend is showing. And on to making prediction with the remaining 20% of my data set. Here is the remaining 20% of my data set, and I bring it in using the print x underscore test, and so I'm having 1 hour 5 minutes, 3 hours 2 minutes, I guess. So, and here my model is making the prediction, and it says that at 1 hour 5 minutes a student will score 16.8 minutes 17. And to understand this better, I send with the rest of the data. And so to understand this better, we I'm gonna compare my actual score with the predicted scores, and here I'm bringing in my actual score and this is my predicted score. So looking at this, the difference between the actual score and what the model predicted is quite small. So I would say that my model would pass for a good one, you know. And on to making random prediction using 20 hours and 3 hours, and my model says these and these are the scores. Then to evaluating the model using the mean absolute error metric, and I'm having 4.1. So that's to say my mean is a good one. Sorry, my model is a good one because the error is quite small, and so my model can actually make predictions with minimal error. So this is the end of my task one. Thank you and bye.